Welcome to this explainer. Today, we are diving into the fascinating and honestly highly misunderstood biological realities of human albinism. We're going to go way beyond those surface-level assumptions to uncover the molecular foundations that will absolutely change how you view human pigmentation. So let's just dive right into it.
So, is melanin just biological paint? Your initial instinct might be to say, well, yeah, obviously. For a really long time, the common misconception has been that melanin is purely a coloring agent. Just a biological paint that dictates whether we have brown hair, dark skin, or blue eyes. But as we're going to see in this explainer, that is only a tiny fraction of the story. We're going to challenge this idea head-on and look at melanin's much more profound structural role.
Here is a quick roadmap of where we're headed today. We'll start with the genetic blueprint, explore melanin as the biological architect, look at wiring the albino brain, move into mapping the genetic subtypes, and finally, distinguish biological lookalikes.
Section 1. The Genetic Blueprint, Unpacking Inheritance. Before we even look at physical traits, we have to understand the fundamental architectural plans that instruct the human body on how to build itself.
Now, albinism isn't just random. It relies on very specific parental genetic combinations. It's kind of like a complex puzzle. The first main pathway is recessive inheritance, which applies to most forms of oculocutaneous albinism, or OCA. The second is X-linked inheritance, which applies to ocular albinism, or OA1. These two blueprints operate by completely different genetic rules.
Let's break down the genetic math here real quick. For recessive OCA, both parents absolutely must carry a specific mutated gene. And even when both parents are carriers, there's still only a 25% chance, a 1 in 4 carrier coin flip basically, that their child will actually express the condition. If only one parent passes it on, the child won't have albinism, but they will be a carrier. Now, contrast that with OA1. Because OA1 is an X-linked inheritance tied directly to a mutation on the X chromosome, it occurs almost exclusively in males.
Consider this staggering number for a second. 1 in 32. In South Africa, roughly 1 in every 32 people carries the recessive gene mutation for albinism. This just highlights a really fascinating reality about our genetic blueprints. These traits are incredibly prevalent, just hiding silently in our DNA across massive populations, waiting for that specific 25% probability match.
And because of that super high carrier rate, the prevalence of albinism in South Africa is actually much higher than the global average. There are an estimated 13,000 to 15,000 South Africans living with the condition today. Oculocutaneous albinism type 2, or OCA2, is the most widespread form, accounting for roughly 80% of all those local cases. It's a perfect example of how regional genetics shape human variation.
Section 2. Melanin, the biological architect. It really is so much more than just pigment.
Okay, now that we understand how the blueprint is passed down, let's talk about the primary building material itself, melanin. During embryonic development, melanin doesn't just act as paint. It actually functions as critical biological scaffolding. It is literally a structural architect that guides the physical development of the eye, particularly in shaping the fovea, which is the part of your eye responsible for sharp central vision and in properly routing the optic nerves to the brain. Without melanin, the whole construction site basically lacks its framework.
Section 3. Wiring the albino brain, navigating the visual system. Let's zoom into the micro level and see what happens when this crucial melanin scaffolding is absent. Without melanin acting as a developmental guide, the visual system essentially misfires. The fovea remains underdeveloped, which means the eye physically cannot produce a sharp, clear image. On top of that, the optic nerves are actually misrouted. The connection between the eyes and the albino brain is uniquely wired, meaning the brain is constantly struggling just to maintain a steady focus. So the really crucial takeaway here is that this internal miswiring results in a very visible external condition called nystagmus. You may have noticed this if you've ever met someone with albinism. It's that rapid, involuntary bouncing or shifting of the eyes. And it's vital to understand that this isn't just some surface-level eye quirk. It is the direct, physical result of the optic nerve misrouting we literally just talked about, all tracing back to that missing melanin scaffolding in the womb. Now, I want to make something absolutely clear right now. While the visual pathways in the albino brain are uniquely wired, this structural difference has absolutely zero impact on normal intelligence, cognition, or overall life expectancy. The brain is entirely healthy and fully functional. It simply processes visual input through a totally different biological routing system. That's it. Moving into Section 4, Mapping the Genetic Subtypes, let's look at visual markers and variations.
How do all these hidden genetic and structural differences actually show up visually in human hair, skin, and eyes? Well, in oculocutaneous albinism, or OCA, a complete lack of melanin affects the whole shebang, resulting in pale skin, white or blonde hair, and affected eyes with nystagmus. But by contrast, in ocular albinism, or OA, the pigment reduction is strictly isolated to just the eyes. A person with OA retains normal genetic pigmentation in their hair and skin, making the condition pretty much invisible from a quick glance, aside from the eyes themselves.
And speaking of the eyes, we absolutely have to clear up one of the biggest myths out there. Albinism does not create red eyes. The eye itself isn't red. Actually, scratch that. It's more like the iris is totally translucent. It's clear. Because it lacks melanin, it can't block light from flooding the eye, which causes severe light sensitivity, also known as photophobia. That red or pink hue you might sometimes see, that's simply incoming light bouncing straight through the clear iris and reflecting right off the red blood vessels at the back of the retina.
If we look closer at the OCA category, we find even more variation. OCA type 1 is the most severe form, characterized by a complete and total lack of melanin. We're talking stark white hair and pinkish skin. But OCA type 2, which, as we learned earlier, is incredibly prevalent in African populations, is different. The genetic mutation in OCA2 actually allows for a tiny bit of melanin production, and that can result in some incredibly distinctive gold, yellow, or even auburn hair pigmentation.
Finally, Section 5, Biological Lookalikes, Distinguishing True Albinism.
Let's clear up one last layer of confusion by comparing true albinism to similar-looking physical traits in other populations. Let's isolate the difference here. Human albinism is the biological gene mutation where the physical scaffolding is missing, resulting in a translucent iris and severe vision impairment, like nystagmus. Contrast this with something like the human Afrikaner phenotype, which features fair skin and natural blue eyes due to European heritage. This is just normal, low melanin production. The biological scaffolding was still present during development, so they have naturally pigmented blue eyes and fully functional, normal visual architecture. It is literally the difference between a missing building block and simply a lighter coat of paint.
We started all of this by asking if melanin was just paint, and we've discovered it is an invisible architect shaping the very way we view the world. It really makes you wonder, doesn't it? If this one single compound plays such a profound, unseen role in building our reality, what other hidden genetic blueprints are currently shaping the human experience right beneath our skin? Thank you so much for joining me on this explainer, and keep exploring.